Hello everyone. Can you hear me out? Hi everyone. Yeah, okay. So welcome all. So today we're gonna. My name is Mayur, as I told you previously also. Yeah, and you already know the previous slides, right? You have seen those slides with the other teachers as well, right? So we're gonna directly start this time. Good evening, very good evening, Shahrukh, Kavita, very good evening. Yeah, Shruti, Charan, Manoj, Salari, Purnima, Lava. Yeah, everyone, very good evening. Yeah, so the very first, good evening, Chetan, good evening, Sarita. Yeah, good evening to all. Okay, so yeah, so our the second next topic which we are going to see today is the combustion and the fossil fuels. Okay, so you must have learned about this, right? You must have learned already about what is combustion, what is fossil fuels, right? So firstly we start with the resources, right? You know what are natural resources, right? Is everyone known with the natural resources? Yeah. Yeah, very good evening, Saritha, Charan, Reddy. So, natural resources. So, there are two types of natural resources. Can anyone tell me how many types of natural resources are there? Yes, which occur in nature. Very good, Manoj. Yeah, they occur in nature. Yeah. Sun, water, O2. Yes, very good, Chinna. Yes, renewable. And the second one is 2, 2, 2, 3, what? Yes, Shahrukh, very good. There are two types of natural resources. Look, natural resources, there are two types, renewable resources and non-renewable resources. You can clearly see here, I have placed the sun here, right? What is this? It's air. You have a sun, then you have air also, sun, air, and the water. This is your air, right? And the water. So the question is, are these resources renewable or not renewable? Yes, very good. Selari, Deepika, Nareddy, Chinna, Lokesh. Very good. Yes. So the resources which I have placed just now are renewable or not renewable? Yeah. So, so the resources which I have placed here are the renewable. Yeah. We know that energy of sun will never be finished. Yeah. As long as sun is there, air, we have infinite amount of air, water also, you have large amount of water. Okay. Now, we know very much about the sun. Okay. So I'm going to give you a solid question. Okay. Very fantastic question today. Look at the question. How large would a bucket of water have to be to put out the sun? If you have to put out the sun with the water, how large would be a bucket of water that you need? Isn't it question fantastic? Yeah, a lot. Yeah, Kujista, very good. My answer is, even if you put, yes, Chinna, you are saying infinity. My doubt to you is that if we put infinite amount of water, or maybe whatever amount of water you have, probably uncountable. Yes, Sarita. Chetan is saying big infinity bucket. Yeah, you can say that big infinity bucket. But my question is, even after putting that much water onto the sun, would you think, would it be really put out? Would it stop burning? Do you think? What do you think? We should not put water. Why, Manoj? Why we should not put water? Because we respect it or what? No, 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 sir. It would not be put. Yeah, but my question is why? Why? Look, consider as the pressure gets creating nuclear fusion. Yes, Rikarkama, you are probably right. Let's consider for instance, you have an infinite amount of water. And if you pour all those water on the sun, then would it put out or not? Sorry. Hydrogen is present, it would heat up more. It's all gas and not fire. Yes, Deepika, you are right. Very good. Chinna, you're also right. Srikar Kamma, you're also right. Okay. Okay. No, no, sir. It burns till the hydrogen completes to convert into helium. Yes, Surya Lakshmi, Anita Uppala. Yes, you are right. Very good. Now we will see. You'll get the answer for this question as we progress ahead. Okay. Now what are this? These are also natural resources. You can see you have a forest here, forest, minerals, oil, coal, wildlife. So are these resources which I have put just now, are these renewable or non-renewable? Non-renewable. Yes, you can also say non-reflexionable or exhaustible, right? Sorry. Yes, these are exhaustible. These can exhaust your forest. If you go on cutting the trees, the day might come which we don't want to come, that all forests would be wiped out. Minerals are obviously finite. Coal, we know that coal, it is present in very finite amount. Oil is obviously, and so is the wildlife, right? So, that's what renewable and non-renewable resources are. Now, again the next question. What would happen if we run out of oil? I'm not talking about the cooking oil, okay? I'm not talking about cooking oil here. The oil that I mean here is petroleum products. Here, the oil means petroleum products, or you can say a petrol diesel. What happens if we run out of it tomorrow? No, Kujista, I'm not talking about edible oil. I'm talking about petroleum products. You can say petrol, diesel, right? Petrol, diesel, white petrol. I'm talking about all that. What if we run out of it tomorrow? We turn towards sustainability or no? So, do you know vehicle won't run? Yes, we'll talk about that. Do you know how many products in your daily life are actually having a petroleum in them? Can anyone tell me some of the? Yes, Chetan, very good. Electric technology would be used. Yes, we are right. But how would you generate electricity, Chetan? Huh? Do you know how electricity is generated, Chetan? Yeah? You're saying electric technology would be used. Got it. But do you know how electricity is generated? Electricity is generated because of petroleum products only. Because there is the petrol, diesel, coal or coke. That's why we actually generate electricity. Vaseline has petroleum. Yes. Now you will know very shortly. You will know very shortly how many products do we have a petroleum in them in our daily life. Okay. Just a sec. Huh. Look at this. How many everyday objects wouldn't exist if there was no oil? Yes, Chinna, you can say infinity product. Look, the first you are saying is bubble gum. Do you know what? Bubble gum has a petroleum product in it. Look at this soap. Soap contains petroleum product in them. Soap, bubble gum, the chewiness and softness comes because of petroleum products only. Very sports equipment. This basketball, football, golf ball, rugby ball, shoes, many of these things actually. The denture of your grandpa is also contain petroleum in them. This carbon, here we are talking about the dyes. You might not hear, but I'm telling you what is going on in the video. These dyes are actually food FDA approved. Whatever dyes you will eat in your daily life contain some petroleum in them for sure. Okay, this petroleum jelly, yes, someone told me the petroleum jelly, yes, petroleum jelly. Lipstick has petroleum in it. It's a Vaseline kind of jelly, yeah, paraffin wax. So if you play the guitar, the strings are actually made up of nylon. That comes again from the petroleum products. Yeah, toothpaste, see, it also contains petroleum. Yes, contact lenses, mask, so many things actually contains the petroleum. We can't actually live without petroleum. One day if you run out of oil, you might not get your favorite pizza and burger also. Why? Petrol will be finished. You can see the vehicles can't move after that. Glycerin petrol product. Yes, Rikar, you can say sort of. Yes, yeah. Petrol price would suddenly hike, right? People might not have that much money. People will lose their jobs. The vehicle transport will be stopped. If the vehicle transport will be stopped, we have to use CNG vehicles. Yes, you can say that. You are right, Chinna. But what about electricity? Flights will be stopped. Trains will be stopped. People will lose their job. People will lose their money, right? Yes, Abhinav. It would be a global disaster in overall. These are the emergency vehicles which might get petrol for some days or diesel for some days, but after all, they will also stop. It will be a global disaster. People need to sustain with the food which can actually be grown. Okay, so these are the must have items. These items would also be stopped. It completely would be a global disaster. And that is why I was telling you this, because you should know how to use it effectively and how to use it, more efficiently, and we should not waste it. It's a gift given by mother earth to us, so we need to value it and we need to use it without wasting it. Okay. Okay. Now, can someone tell me how do actually petroleum product gets formed? How petroleum was actually formed in the earth? Can you tell me? Yeah, how petroleum was actually formed? Yeah, it's a fossil fuel. You're right, Saritha, Lydia, you're right. We call it as fossil fuel. Why do we call it as fossil fuel? Because it actually formed from the dead remains. It actually formed from the dead remains of a living organism. Okay, deposition of plants in the river bed, or you can see in the ocean. Look at this GIF for that. These are the phytoplanktons or zooplanktons which have died a million or billion years ago. Okay, they converted into kerogen, and more soil was actually deposited on them. As this soil was deposited on them, slowly they started converting into useful product. Initially, see, they form this carbon, they form this hydrocarbon. We call them as hydrocarbon. Look at this slide. This typically gasoline molecule. By digging the seas and oceans, yeah, degradation of biomass buried deep under the earth for millions of years ago. Yes, Samisha, very good. So this Soil gets deposited over that biomass for the million years. See, it kept on depositing for many million years, and that's how slowly your petroleum products was actually formed. These are the oil reservoirs. Yeah. Gas reservoirs. See, this is our city, and that's beneath the oil reserves are. They are very much deep inside the soil. Okay, that's how petroleum product were actually formed. Okay, now let's look at the refining of petroleum. Whatever petroleum that we get, how do we refine it? Look, this is heated crude oil. Okay, and when you process it, you actually get, this is gas, this is called as petroleum gas. Yeah, then you get the petrol that we use, naphtha, kerosene, diesel, and bitumen. Do you know what bitumen is? You can see the bitumen at the bottom. What is it? Yes, Shahrukh, very good. Distillation, Abhinav. Yes, you are right. Fractional distillation. Fractional distillation separates the petrol, naphtha, kerosene, diesel, because all of them have difference in their boiling point. Their boiling points are different. So based on that, we can actually separate them. Yes, Abhinav, very good. Bitumen actually used in layering the roads. They are used in layering roads. Yeah, it's a black color, thick colored substance. Okay. Yes, Manoj, on the density also. Okay, but the boiling point is one of the main fraction. Boiling point is actually basis for the refining of the petroleum. Yeah, that was it for the petroleum. Okay, now let's go and look at the next part, which is the combustion. Next part is combustion. What is this? When do we use this? It formed from the ancient dead organisms. Yes, you are right, Jhansi. You are right. But that is what with the petroleum. We are done with it. Okay, now let's move ahead with the combustion. Yeah, you know this. This is wood. What is this? It's a charcoal, right? This is your charcoal. How do we form charcoal? Charcoal is formed from the wood only by burning in absence of air, or we can say oxygen. In absence of oxygen, in absence of air, if you burn, you get the charcoal, and charcoal burns very effectively. Okay, and this is cow dung, you know this, right? So my question to you is, what is mean by combustion? Before moving to that, what is mean by combustion? Coal gas are obtained from combustion. Yeah, that you are right, Srikam, but here I am asking, what is combustion? What do we mean by combustion actually? Burning of fuels, burning of a thing in presence of oxygen. Yes, Kujista, you are right. Burning of any substance in presence of oxygen is called as combustion. Okay, that is what the definition is all about. So this is what happens in combustion. Look at this. You have a CH4. This is called as methane. So methane has 4 hydrogen. Reaction with oxygen, it gives you CO2 plus H2O. Basically, you have a CH4 methane. If you burn it in presence of oxygen, you get CO2 plus 2H2O. This process is called as combustion. Okay? Yes, Chinna, you are right. Burning anything in presence of oxygen would be called as a combustion. Okay. Now we know that woods can be burned. This cow dung cakes can be burned. Many substances can be burned. Can metal also undergo combustion? Can you tell me, can metal also undergo combustion? Combustion gives some oxides and energy in the form of heat. Yes, Shahrukh, you are right. Yes, yes, yes. Very good, very good. Surya, Sujista, Neddy. Look at this. In the previous lecture, we saw the alkali metals reacting with the water to give you hydroxides plus hydrogen gas. Here, this lithium, sodium, potassium, strontium, copper, they also burn, they also undergo combustion to give this beautifully colored flame. Lithium gives you this slightly, what I would say, a scarlet colored flame. Okay, strontium gives you bluish, sodium gives you yellowish colored flame, copper gives you greenish blue, and potassium also gives you red colored flame. So why do this happens? If you take any metal, for example sodium, if you burn sodium in presence of oxygen, you need to take 4 sodium, it gives you 2Na2O. This is called as sodium oxide. So sodium oxide you get, and this also releases a lot of heat, and obviously it is colored, you know that, you just saw it. Okay, so that's what the combustion is all about for the metals. Yeah. Okay, let's move ahead now. So do you know how many types of combustion there? You know it, right? The complete combustion, incomplete combustion. What is mean by complete combustion? Complete combustion is the one which you get whenever this wood reacts with oxygen to give you CO2 plus this. What is this? What is it? It's a water drop, right? This is nothing but your H2O. So by burning anything, if you get CO2 plus water, that means it's a complete combustion. It's a good combustion. Okay. And what is mean by incomplete combustion? Incomplete combustion is any combustion which gives you CO2 plus water and the CO. What you have got here is, what is this? CO, carbon monoxide. And carbon monoxide is what? It's a deadly, we know that. Complete combustion doesn't leave any residue, whereas incomplete combustion does. Yes, Deepika, you are right. You are right, very good. So complete combustion gives you CO2 plus water. Incomplete combustion gives you CO2, water, but along with that, it also gives you a deadly poisonous gas, which is carbon monoxide. Okay, so that is what combustion is all about. Yeah. Now, that is why whenever you see, if suppose if any home or house, if it is set on a fire, whenever this fire brigade people come, they make sure that there is no casualty there, not only because of burning, but also because of this carbon monoxide gas. And that is why it is recommended not to sleep in a room where there is a combustion going on, whenever there is a combustion, and if the oxygen is less, combustion would still be kept on. Okay, if there is a less amount of oxygen, it would give you a carbon monoxide, and you may die while sleeping only. It is that deadly. Okay, do you know how carbon monoxide kills you? Do you know how do you get killed when carbon monoxide comes in contact with you? Yes, Shruti, can you tell me? Yeah, you're right. Not sitting in front of. No, it's not like that, Shruti. You can't sit in front of a bonfire. There is no issue with that. It's just that you cannot sleep there. Yes, it irritates, right? It does irritate. The thing is that you cannot sleep in a room while there is a combustion happening. Selhari is not a slow poison as such. Let me tell you what actually happens. See, whenever you breathe, cannot breathe, blocks oxygen from pairing with RBCs. Yes, Deepika, you are right. See, this is your hemoglobin. See, whenever you breathe, what happens is that your hemoglobin reacts with oxygen. Okay, it gives you oxide. This goes to your lungs and then your hearts and then your whole body part. But whenever there is a CO, what happens? This Hb combines with CO and it doesn't let oxygen to combine with it, and this is not at all good. This blocks oxygen from reaching to your vital organ, and that can kill you. That means the CO2 that you have inside your lungs, that CO2 also doesn't come out, and oxygen also doesn't reach to lungs, and that is why it kills you. It gives you suffocation. Yeah, a double suffocation. So that is why carbon monoxide is deadly. Yeah. Okay. Okay. So now we'll move ahead. We'll see some other part of combustion also. Okay. Do you know how does matchstick actually burns? We're gonna see a very interesting video first, and then the principle. How does actually matchstick burns? Okay. Look at this video. You might recognize him. You might have seen him before also. Yeah. Look at that slow video. On the basis of scratching. Yeah, I'll tell you what the mechanism is actually. Look at this video once again, how slowly it actually burns. See that first part, second part, third part, fourth part, like that. Jasi, H2O plus CO. It's not that straightforward, beta. Okay, chalo. Let me tell you the history of a matchbox today. Okay, it is a very usual object we see in everyone's home, right? We have it, but it has a very interesting history. Look, maybe around maybe I would say around 1600 years ago. That means it's a 400 AD. That in that time, what these Egypt people do, they used to take a stick, and that stick was actually immersed in the sulfur, and if they rub it against any object, it will burn. Okay? But as the time progressed, just recently, that means hardly 200 years ago, the first matchbox was actually formed. Now that matchbox contained what? That matchbox was actually containing arsenic sulfide. Okay, along with that it has KClO3, which we call as potassium trichlorate, sorry, or you can say potassium chlorate, along with a white phosphorus. So all of this mixture was actually applied on your matchstick. This is your matchstick. So this three mixture was actually on your matchstick. Okay, and this is your matchbox. Okay, let's suppose this is your matchstick. Okay, now whenever you rub this against this surface of your matchbox, this surface actually contained powdered glass. Okay, it contained powdered glass plus some glue here and there. Okay, so whenever you struck this against it, what happened is that this white phosphorus burns. As soon as white phosphorus burns, it burns KClO3 also, and this KClO3 burns arsenic sulfide also. So you saw these steps in this video, okay? It seems very easy, but what happened here, this is how the old matchbox were. This is how the old match boxes were. So what used to happen, the white phosphorus that you have on this stick, white phosphorus can catch a fire immediately. White phosphorus, if the temperature arises, suppose around 30, 38 or 39 degrees Celsius in the hotter areas, the white phosphorus catches the fire immediately. And many times what happened is that this white phosphorus sometime also used to catch a fire in the pants of people. Suppose if you have a matchbox with you, and if you have wear the lungi, and if you have placed the matchbox in it, and suppose if you have gone for some work in the sunlight, and if the temperature is around 38, 39, it used to catch inside the lungi also. So this has happened, okay? This has happened with the people, and also with the, it is also not safety for the people who live, with the people who uses, I mean the users as well as the factory workers. It was very risky because many of the people have died in this process. So that is why these old matchsticks were actually replaced. They were replaced, okay, and then the new matchsticks was actually formed. Okay, I'll tell you what is in the new matchstick. So yeah, it has happened with the people. In many times, people's lungis were used to set on fire. Yeah. ठीक है, चलो. So I'll tell you now what is the modern matchboxes are. In modern matchboxes, what they're done. So basically, the white phosphorus is very risky. White phosphorus is not good. So what these people had done, in today, in the current matchbox that we have, we call them as safety matchbox. Why do we call them as safety matchbox? Because in this stick today, you have only arsenic sulfide plus KClO3. Okay? Whereas with the matchbox that you have here, this matchbox contains red phosphorus and glass. That means powdered glass, the powder of glass to generate the friction. So what happens when you have this matchbox here? Okay, this is your matchbox and this is your stick. Whenever it is rubbed against it, what happens is that this red phosphorus that you have here, this red phosphorus burns because you rub it against that surface. Okay, when you rub it against that surface, it produces a heat. Shruti Gupta, glass means powdered glass. I mean to say powdered glass, so that we can cause a friction, because you need a friction here. Okay, so whenever you struck a matchstick against a matchbox, what happens is that there is a friction because of powdered glass. So whenever there is a friction, because of friction, red phosphorus catches a fire. This red phosphorus on hitting gets converted to white phosphorus. This white phosphorus then burns KClO3. This KClO3 then gets decomposed to give you KCl plus oxygen, and also it produces heat. So this heat then further ignites whatever heat you have generated here. This heat ignites the arsenic sulfide at the last. That means, so whenever you rub a matchstick against the matchbox, what happens? The matchbox surface containing red phosphorus. So because of friction, the heat is generated. That heat makes sure the red phosphorus gets converted into white phosphorus. White phosphorus, when it burns, it produces further more heat. That heat decomposes KClO3 into KCl plus O2 plus along with that it also releases heat. So that released form of heat then ignites the arsenic sulfide. So that's the last part. Okay. Don't you need hydrogen for something to burn? Srivatsan, yes. Look, hydrogen is good for burning, but not necessarily you need a hydrogen only. Other than hydrogen also, you can burn the things. Okay. I hope that must have been clear to you. So do you understand how matchboxes actually works? Yeah. So remember, next time, be careful with the matchbox and make sure that your mouth doesn't come in contact with any part of matchbox. That is why it is generally being kept away from the children. Okay. Okay. Chalo, let's move ahead. Look at this video. See, it contains sulfur, oxidizing agent, potassium chloride. Not actually sulfur. Yeah, you can say sulfur. Actually, it is phosphorus. Sand, powdered glass, red phosphorus. It burns. Yeah. So when you do that, yes, it's actually through a 2-3 step process. Okay, it doesn't happen immediately. It takes time for that to happen. Okay, but what we see is very fast process. Okay. Okay. Chalo, let's move ahead. So, how many of you know about the forest fire? Yeah. You know about this forest fire, right? Will mastic burn if it's rubbed against any rough surface? Yes, Deepika, it may. It may. Well, some people can do it, but not. That's not necessary. That means it can burn against any rough surface. Okay, not necessarily. Matchbox is the ideal thing for it to rub. Okay, for any other surface, yes, it may or may not, depends. Dry sticks rub each other. You try doing it, Manoj. Try doing it. No, Shruti, it doesn't happen because of just wind only. See, if there is a if there is a dry grass in the forest, and if some of the wood, if they are rubbing against each other, it produces a spark, and if that comes in contact with the dry grass, it may catch a fire, and then with the help of wind, that forest fire actually spreads. Okay, there are many human activities also which are responsible for forest fire. Can anyone tell me how many for anything to burn, how many things are important? Can you tell me? Yes, Rikar, you are right. Lightning also. Lightning is also one of the reason. Will the mastic burn when it is in contact with the hot stuff substance? Yes, Chetan, it can burn. It can burn, yes. Abhinav Padishetty, 2 things. Devansh Jivan, 3 things. Abhinav again, 2 things. How many things you required for anything to undergo a fire or anything to undergo a burning? Friction, dry grass. Yeah, we done with that. We done with the forest fire. Yes, look at this. Fire triangle. So this fire triangle, you can see you need a fuel, oxygen, and the heat. You need these 3 things to burn. See, even if you have a petrol, if you have any tanker filled of petrol, and if you burn the matchstick, if you put into the petrol tanker, it will not catch a fire. You might have seen people showing this in the movie, but it actually doesn't happen. If you do that, the matchstick will just put out. It will just put out. The petrol tank will not catch a fire. The petrol tank should have at least some heat. That is called as ignition temperature. Yes, sticker, very good. It's ignition point. The petrol has to reach to its ignition point. Then and then only it can catch a fire. So heat, which I'm saying here, should also be responsible to increase ignition temperature. Acha, tell me one thing. if something is burning, if you put a water into it, we know that many of the objects, I'm talking about a normal fire, okay? If you're talking about normal fire, and if you pour a water into that fire, it gets put out, right? We know that the fire just stops. My question is, what actually happens in that? The petrol that is in gas form can catch a fire. Yes, Devansh, you're right. So basically, this is a fire triangle. You need a oxygen, you need a fuel, and you also need a heat. These three things are, if these three things are there, then and then only you can actually burn anything. Reduce the temperature of substance, which reduces the ignition point. Yes, Deepika, very good. So whenever you pour water onto the substance which is on a fire, if you put the water onto it, what actually happens is that the water decreases the ignition point of that substance, and that is why the fire actually gets put out. Okay, but water the water cannot extinguish the fire of every object. Okay, it cannot do that. You cannot take any other object, just put the water into it and it will extinguish. Okay, there are some objects, for example, if you have a fire caught by, suppose, paper plus wood, or any normal home article, which we have in our house, other than gas and oil. Okay, so for them this water and this can work. Now tell me, suppose petrol is burning, suppose if there is a house which has caught a fire and someone has set that house on a fire by using a hot petrol. So by pouring of water on it, can we extinguish the fire? Can we extinguish the fire by pouring of water on it? When the fire is because of petrol and oil? No, sir. Even when throwing sand puts out the fire. How, sir? Let me tell you, Chetan. Yes, very good question. Yes, Abhinav, you are right. Chinna, a little bit can. Yes, you are also right. It will blow. No, look, let me tell you one thing. See, water can decrease the ignition temperature for a bit. You are right. When you put the sand over any object which has caught a fire, what happens? When the sand covering that, whenever sand covers the object which is burning, what happens is that sand cuts off the contact of oxygen of the air with that object. And when you have no oxygen, that object can't be burned. You got it? So by putting a sand actually cuts off the supply of oxygen to that article, because of which it was actually burning, and that is why you can extinguish the fire of a petroleum by sand also. And yes, some of you also told me CO2. What happens with CO2? This person, whatever he's holding, in a funny way, obviously, it is CO2 only. What does CO2 do? CO2, whenever you spray a CO2 over the fire, what happens is that CO2 gets spreaded over the complete object. Whenever CO2 gets spreaded over the complete object, it makes sure that oxygen supply is also stopped. Whenever oxygen supply is stopped, obviously the fire will definitely get extinguished. Okay, yeah. So I hope this must have been clear to you all now. Yeah. CO2 covers the object and blocks oxygen, which is necessary for combustion. Yes, Deepika, you are right. Very good. See, this is the one image which I have here. You can see here, I'll read it for you. The water, CO2. Okay. Now you cannot see this class of fire A, B, C, D. In A section, you can see they are written paper, wood, glass, plastic. So this this can actually extinguish by using water only. If you put the water, it can extinguish. Foam blanketing, yes. But if you use a dry chemical power as a blanketing, no, that is not good. That's a wrong. Okay, so this is the complete list. When you have a petrol, oil, paints, thinners, spirits, if these things have caught a fire, water cooling is not good. Foam blanketing, yeah, it's good. Dry chemical blanketing, yes, that is also good. ABC power blanketing, that is also good. So this is a complete list. When you have flammable gases and electrical fire, then the water is completely prohibited. You cannot use the water there at all. Okay, in that case you can only use the dry chemical powder blanketing, okay, or CO2 gas blanketing also. And the last from the D section is magnesium, sodium, potassium. So when you have metals caught on fire, for example magnesium, sodium, potassium, we know that we cannot put a fire on it. Sorry, we cannot put a water on it, because if you put a water on the metal which has caught a fire, you know what will happen. It will literally blast. We had seen that how alkali metal reacts with the oxygen. So here alkali metal has already got a fire and you are putting a water into it. It is like pouring a petrol on the object which is already burning, right? So water is not good. The foam blanketing is also not good. Dry chemical power blanketing is good for it. And CO2 will also not work there, because that CO2 then would react with the alkali metal. So this is the complete list. Okay, you might have seen this list in the parking lot of your society also. Okay, now answer to your question. I asked you the question in very first or maybe first or second slide, that how much water or how many buckets of water do we need to put out the sun. Okay, now look at this. Now what happens in sun? Hydrogen combines to give you helium. See this reaction. Hydrogen combines to give you helium plus energy. So this is nothing but, we call this as nuclear fusion. And no matter how much water you put onto the sun, this fire will never extinguish. Why? Because this fire is because of nuclear fusion, and sun is not actually burning. It is not a combustion. See, if there is a combustion, you can put it out by using water. You got it now? In sun, 2 hydrogen atom combines to give you helium plus energy. So if had it been a combustion, by pouring a water into it, it might have got extinguished, but it is not a combustion, it is a nuclear fission. So by putting a water into it, nothing will happen. That means no matter how much water you pour onto the sun, it will still kept on undergoing a nuclear fusion. It is not a combustion, it's a nuclear fusion. Okay, we are giving it more material to fuse. Yes, there was demon. Bingo, there you got it. Actually, there you got it. We are actually giving more material for it, because the heat of the sun is so enormous, it is so huge, that if it comes in contact with water, the water will get split. Do you know what will happen with this nuclear fusion? There's so much heat is there, it will extinguish water into 2 parts. That will give you hydrogen plus oxygen. The hydrogen the sun is already having. So when you put a water will also get decomposed. It will give you hydrogen and oxygen. So that hydrogen will again get converted into helium, will again release energy. So this thing will keep on happening. So that's the thing it's all about. Okay. So I hope this must have, it will evaporate, but where will it go? It will not only evaporate, Chinna, Pentya, it will actually get decomposed, because better we put liquid nitrogen on sun. We don't know, Shruti. That might also get decomposed. The heat of the sun is very, very high. It is not that, it is around 4 or 5,000 degrees Celsius. So at that much high temperature, you don't know what happens. Okay. So now you are clear with this? Yes. Chalo, go to the next slide. Now, types of combustion. You can see here, there are different types of combustion. For example, rapid combustion. So what is this rapid combustion is all about? This you are seeing, it is, what is this? It is nothing but containing a gas. It is containing a gas. It contains gas. So it undergoes a rapid combustion. What is spontaneous combustion? Spontaneous combustion is like phosphorus catching a fire. We had seen this previously. So this gives you phosphorus pentaoxide. या फिर sulfur catching a fire with oxygen to give you SO2. We saw that in the previous slide, right? The spontaneous combustion. It's just that I did not tell you that time that phosphorus on reaction with oxygen catches a fire to give you phosphorus pentaoxide. Sulfur also reacts with oxygen to give you SO2. So it's like that. Rapid combustion contains a gas. And what is explosion? We can use this method to get more oxygen, sir. Yes, you can say that. And explosion is what? Explosion is sudden release. Explosion is sudden release of large amount of a gas with heat. Explosion is nothing but a sudden release of a large amount of a gas along with heat. So whenever that happens, you see an explosion. Spontaneous combustion is what? This metal, non-metal, whenever they catch a fire, that is nothing but a spontaneous combustion. We can tell without any external fire, it can go combustion. Yes, you are right. So any combustion which happens even in absence of any combustion which happens even in absence of any burning material is called as spontaneous combustion. Okay? Yeah. Chalo. The last slide is nothing but this. What is this? It is also kind of a combustion, right? You must have seen this. So what is this? Is spontaneous combustion or what? It is actually contains all sort of. Do you know what? The firecrackers that you are seeing, this firecracker is having spontaneous combustion plus a little bit explosion also. Little bit explosion, spontaneous and rapid also. That's why I have put this deliberately there. Firecrackers actually they shows the combination of rapid combustion, spontaneous combustion as well as little bit explosion also. It is combination of all these three types of combustion. Okay, so that's it for today. Yeah, guys, I hope you must have enjoyed the session where you come to know the different the different aspects of the combustion. Okay, and the petroleum product also. Okay, yeah. That's it for today. Chalo, bye everyone.